Hi, everyone. Welcome to another ACE session. So ACE hosts multiple machine learning talks, live streams each week. And, very happy to have you with us today. And today we have Hari, who will be talking about ML in marketing. And just let me introduce Hari really briefly before passing the floor to him. So right now, Hari is a data scientist at EQWorks and was previously at Canadian Tire. He holds a PhD in mathematics from the Ohio State University. I'm very excited for this talk today for ML in marketing, so I'll pass the floor on to you.
Okay, thank you, Susan. So today's talk is just going to be a talk about, I'm just going to give you a big picture of how machine learning is used in marketing. It's basically going to be, you can think of it as a map of the world in some sense. I'm not going to go into the details of the field specifically. I'm just going to give a big picture without focusing on the techniques. And hopefully this will serve as an introduction to what should be the machine learning and marketing stream, which should start shortly with talks by other authors. So without further ado, let's get started. The first thing I want to do is I want to talk a little bit about, and before we start talking about the machine learning aspect of it, and which we will get to eventually, what I'd like to do is talk about marketing. What do we mean by marketing? And the idea here is you want to think of marketing as just a way of communication. It's just a way in which a firm or a product or a brand really communicates with its customers. And the goal of marketing is to do this communication as effectively and as efficiently as possible. So in order to help us in this, there is a kind of a framework. It's called the marketing mix. It's a framework that's been around for a long time. So there's nothing new in this. It's called the 4 Ps of marketing. And nowadays there are even some cases where you have the 7 Ps of marketing. But for our purposes, we'll stick with the 4 Ps. And the 4 Ps of marketing are product, price, place, and promotion. And just to go into this very quickly, price refers to what you pay. What should a customer pay for a product? And a product would imply, well, what is the item that the brand or store or manufacturer is offering to the customer? What are the product features, for example? Place. Place refers to availability. It refers to product discovery. How convenient is it for a customer to buy a certain product? And promotion. Promotion refers to the main channel of communication between the customer and the brand. And the way you want to think of this marketing mix is you want to think of the marketing mix as basically variables that can be influenced for decision making. So these are variables or concepts that are going to prove influential for any kind of marketing decision making that you want to make in the future. We'll come back to this marketing mix in just a moment. But before we do, I think it's worth talking a little bit about the history of marketing science, because really what we're doing right now and in the future slides is we're going to be talking about really what is traditionally called marketing science. So machine learning is probably a recent addition to this, but statistical and other mathematical techniques have been used widely. In the first era, and you could kind of characterize this into 3 or 4 eras, really. The first era occurs right after the Second World War. Because in the Second World War, operations research came into its forefront. And once operations research was used heavily in the management of troops or supply chain problems, very naturally, operations research and management science techniques or methods began to be considered in a marketing context. And that probably is the beginning of this marketing science field. It's where you start thinking about things quantitatively, whereas previously you might have thought of marketing as a qualitative practice. Now it becomes something more quantitative. So, for example, here the techniques were very general. They were kind of general techniques. They weren't very specific. For example, whenever a question of the model dynamics or something came into play, people would use stuff like differential equations. Now, the issue with using these very generalizable, very broad techniques is that they really aren't very successful. So very naturally, when you encounter the second era, you see the rise of specificity. So basically, there's a proliferation of models, and now what you have is you have very specific models being developed for very specific problems. Instead of doing a one-size-fits-all approach, you start considering very specific problems, and then you try to develop models that address those issues. And some of those issues are going to be stuff like basically product decisions or pricing decisions. And along with these proliferation of these variety of models that suddenly entered the field, what happened in 1979 is probably a seminal moment for this field, where there was a market measurement and analysis conference. This was started by two professors, one of them at Stanford and one of them Cornell. They're both marketing professors, and it was called the Market Measurement and Analysis Conference. This conference proved to be very successful, and a few years later, this conference was it started being called the Marketing Sciences Conference. And with the success of this conference, very naturally, in 1982, a journal was formed, which was called the Marketing Sciences Journal. And with that, this field really came, it really became alive in some sense. I mean, you suddenly had people talking about a variety of techniques used in a variety of problems. And the quantitative nature of this field became firmly embedded in marketing. The other main development that happened in the 1980s is what you call the scanning revolution. Now, suddenly, what happened in the 1980s is that there was a lot of data that suddenly became available. You had panel data, you had telephone data, you had customer transaction data hidden in databases. And finally, you also had a lot of data that could be obtained via devices, scanning instruments, which could capture store level or even customer level purchase or transaction data. So suddenly, not only did you have these techniques that were developed a few years ago, now you also have data that you can apply to these techniques. And this wealth of data leads to the 1990s, where the idea of marketing decision automation comes into play. So now you're talking about not just developing specific models for specific problems. What you're trying to do is you're trying to capture the entire marketing process and automate that process with these specific models in production. So that's the era we are in right now. And maybe, and this is something that I borrowed from and it's a very good I think it's a very good framework or a very good template for understanding what we're doing right now. Is that when we talk about marketing decision automation, really what we're talking about is we can think of it as algorithmic marketing, and this is an abstraction. This is not necessarily how things will be in any kind of a retail company or any kind of a brand. So what do we have here? Well, what we have here is the business. We have a business objective. It could be something like increasing ROI, increasing sales. This business objective is fed into a marketing system. Now, what I want to emphasize here is that this marketing system isn't some monolithic entity. It isn't some program that resides in a server. It could be a team of people, or it could be multiple teams of people. It really depends upon the kind of structure you have in that retail or commercial organization. But basically, what you have is you have some kind of a system that takes in these objectives, and then what it does is it decides to basically come up with actions or marketing actions that are influenced by these objectives. So you get an objective that's, let's say, increasing sales or increasing ROI. You make a few, this marketing system makes a few decisions, tweaks a few things, then enacts a few marketing actions. Now, once these marketing actions are deployed into the market, then what you have is you have a natural feedback cycle. Depending on whether these actions are successful or not, the marketing system can then decide to persist with the decisions they made earlier, or the marketing system can tweak or change the decisions they made to further influence these business actions. So what you have here is you have essentially a feedback loop. And this is a feedback loop in which machine learning fits in very well, or really any kind of optimization problem, because at its core, this is what you're dealing with. You're dealing with an optimization problem. you have a few actions, you have an objective, and what you'd like to do is basically iterate through the actions so that you achieve the objective in as optimal a manner as possible. So again, this is an abstraction. This is not necessarily how things will be. In my experience, a marketing system isn't some kind of unified entity. It's usually split across a variety of departments. But at the end of the day, thinking of it like this it will help you in understanding when and where these machine learning or any kind of other techniques will fall into place. So let's go back to the marketing mix. Now, the marketing mix, as I said before, is basically these are variables that you can use to influence decision making. But the problem with the marketing mix is that these are this concept. It really is a concept of answering the question of what do we have? What do we have? We have products, we have prices, we have places, we have promotions. But from an implementation perspective or from a machine learning perspective, the what really isn't the question that you want to ask yourself. Maybe what you want to ask yourself is how. How are we going to execute these marketing actions? And so what we can do is we can basically break the marketing mix into functional services. And so as you can see here, now this is where an element of subjectivity comes into play. As you can see here, different people may have different ways of characterizing or splitting these functional components. But essentially, we can have 6 different marketing services. And these 6 different marketing services are grouped into 3 subfields. The first 2, promotions and advertisements, basically ask the question or answer the question of how do you match customers and product offerings. So basically, you have an entity called a customer. You have an entity corresponding to all the products that a brand has. And what you'd like to do is you'd like to match these 2 entities. And this is done by promotions and advertisements. This subfield of matching customers and offerings, it basically addresses the domain of price and promotion. So if we go back to the previous slide, we have price and we have promotions. And basically, this subfield deals with those 2 concepts of price and promotions. The next subfield deals with product discovery. So now what you have is basically you want to surface the right kind of products to your customers. So this is done mainly through search and recommendations. This is quite distinct from promotions and advertisements, because in promotions and advertisements, what you're doing is you're not just surfacing products to customers. The real question that you're asking is, well, how do you identify customers who can be incentivized by these promotions and advertisements? So you're not matching products with customers. That on the one level, that's what's going on. But on the other level, you are not targeting the entire customer base. You're targeting a specific group of customers who are very likely to respond to the kinds of promotions and advertisements that you have at your disposal, or the kinds of marketing actions that you have at your disposal. Finally, the last subfield, it consists of basically pricing and assortment. And here, what we're doing is we're trying to optimize the set of product offerings and the set of product properties to your customers so as to maybe maximize profit. So what does this entail? Well, what this entails is some kind of price optimization. It might also entail some kind of demand forecasting. So for example, let's say you have a store. At a store, you have a very limited amount of space. So what kind of an assortment would you put into that store? What kind of diversity of products would you want to go for? You wouldn't want to waste shelf space on something that isn't likely to be bought by the customers visiting that store. So questions like this, again, fall very neatly into this third subfield. Now, In the following slides, I'm going to mainly focus on promotions and advertisements. This is partly out of a necessity for expediency. If I went through all the three subfields in great detail, we'd be here for quite a while, much longer than the allotted time available to me. But the other thing is that search is a field that has a lot in common with NLP and other associated techniques. So when we talk about search, we naturally drift into techniques that are available. For example, the aggregate intellect has a specific NLP stream. So semantic search is something that's very common, it's something that's very desirable by a brand. Recommender systems are ubiquitous in machine learning applications. There are a lot of recommender systems out there, some of them available as a service. AWS has one, Google has one. And again, there's a separate stream that deals specifically with recommender systems. So I'm not going to go into so much detail, but just because these fields have been exposed to people very heavily. And I don't feel that promotions, how machine learning interacts with promotions and advertisements has been delved into all that deeply so far. So the idea here is, we're going to spend the next few slides talking about promotions and advertisements. Okay, so when we talk about promotions and advertisements, what we're really talking about is targeting campaigns. What you have is you have a group of customers available at your disposal, and what you'd like to do is target them very specifically based on certain objectives. So in order to be a little bit more specific and in order to structure the following slides and conversation a little bit clearly, let's basically identify three main components of any kind of targeting campaign. So what you have here is a targeting campaign, and under the umbrella of this targeting campaign, you have promotions and advertisements, and you have three distinct components of a targeting campaign: a planning component, a planning phase or component, an execution phase, and a measurement phase. All three phases are equally important. And probably you could argue that the most important phase is the planning phase, and which is why I do want to spend a little bit of time going into that before we move into the execution and then the measurement phase. So, planning. Well, the question of planning is really a question of quantifying your business objective. And in this field of algorithmic marketing, the idea is to quantify things as much as you can. Quantification is the name of the game. And the idea here is, well, when you're going to execute a certain targeting campaign, you have two kinds of goals at your disposal. The first one could be a short-term goal, maybe a brand, and by a brand, I refer to a store or a manufacturer. So what this brand would like to do is maybe just maximize sales. So sales maximization is one short-term goal. ROI, marketing is an investment. You're investing a certain amount of money, and what you'd like to see is you'd like to get a return on investment. And there are these metrics available to marketeers, and so you can very easily calculate or even forecast return on investment for a marketing action. These are short-term goals. So these short-term goals are basically designed to increase something, a certain quantity, very quickly, or maybe what you'd like to say as soon as possible. On the other hand, what you have are long-term goals. Now, long-term goals are a long-term plays. And what is an example of a long-term goal? An example of a long-term goal is something called a life cycle-driven campaign design. So basically, what do we mean by this? So what is an example of a life cycle-driven campaign design, and how is it different from a short-term goal? So what in the long-term goal, what we're going to do is we're going to define what is called the customer life cycle. And in the customer life cycle, what are we doing? Well, basically, what we're doing is we are segmenting the phases of interaction that a customer has with a brand. Traditionally, there are three main phases of interaction. There is an acquisition phase, there is a maximization phase, and finally, there is a retention phase. So what are these three phases and what do they correspond to? Well, basically, in order to answer that question, you just need to think of the relationship between the customer and a brand. In the acquisition phase, the customer is new to the brand. The customer has probably just started interacting with the brand. So he's just been acquired by the brand. And as a result, what you see here is that in the acquisition phase, the customer probably is a little tentative. He isn't interacting with the brand all that much. So what you can do then is, let's say that the customer becomes embedded in the brand. Maybe he or she begins interacting with the brand a lot more frequently. So then you move into the maximization phase, because now the customer is embedded in the ecosystem of the brand. So this customer could probably have joined a loyalty program, or this customer just happens to frequent the store or brand very frequently. Maybe what you'd like to do then is you'd like to bring the customer to the store more frequently. You'd like to increase their basket size. So what that means is you'd like to get the customer to spend more each time they visit. So this is what is called the maximization phase. Again, you're changing the nature of the relationship. Initially in the acquisition phase, the customer was a bit tentative. The customer was a bit hesitant. In the maximization phase, the customer is firmly embedded in the marketing ecosystem. So what you'd like to do is you'd like to basically try and, in a sense, exploit the nature of the relationship between the customer and the brand. And finally, in the third phase, you have the retention phase. And this is probably the tail end of the customer life cycle. Maybe what has happened is that the customer no longer is tied down to the brand. Maybe there are other brands that are competing or vying for his attention. So maybe the customer then is at the risk of churning away from the brand. So this is where churn models come heavily into play, because what you'd like to do is you'd like to identify those customers who are at a risk of churning out. If you can identify them very quickly and with sufficiently early on, that gives you time to deploy a marketing action to try and retain the customer. And this is very important nowadays. This is why churn modeling is, very. It's quite ubiquitous in machine learning modeling, and that is because there's a lot of competition out there. There are a lot of brands out there. There are thousands or tens of thousands of brands all vying for a person's attention, and most customers probably that sense of loyalty that they have is probably not as deep as it used to be before. So firms frequently have to deploy these kinds of marketing actions or marketing techniques designed to retain customers. So the idea behind the long-term goal is to basically see where a customer lies in this life cycle. Are they in the acquisition phase? Are they in the maximization phase? Or are they in the retention phase? And depending on which phase they're in, the idea is to either, if they're in the retention phase, is maybe to push them back into the maximization phase. If they're in the maximization phase, hopefully let them stay there. If they're in the acquisition phase, you'd like to move them on to the maximization phase. So the idea here is a long-term goal wouldn't just be trying to maximize the amount of dollars you can get from a single customer. It would be something more subtle. What you'd like to do is you'd like to push them on in this journey, in this customer journey. You'd like to get them at the sweet spot where a customer is embedded into the brand and where you can get as much, where you can retain the loyalty and the customer dollars or the customer share as much as possible. So here is an example of where, I mean, this is a very rough picture, but here's an example of where an incremental marketing action can have a big difference in outside of a short-term goal. So it's a picture showing you, so the black line shows what would be a traditional or typical customer lifecycle journey. So the customer is probably currently somewhere in the maximization phase, and this person would continue on and finally slowly just fall into the retention phase. But here, owing to a timely and effective marketing action, what you can probably do to a customer is you can increase the amount of dollars that can be obtained from the customer in the maximization or retention phase. So here the red line refers to the customer behavior after the incremental marketing action. The black line refers to what would have been the baseline behavior. The red line refers to a behavior that has been changed because now the customer's relationship with the brand has changed owing to that incremental marketing action. So a timely and effective incremental marketing action isn't just a question of increasing ROI, increasing sales. It's also a question of dynamically or inherently changing the nature of a relationship between a customer and a brand. So now we talked a little bit about planning, and then you can have short-term goals, you can have long-term goals, and that falls strictly into the planning purview. What are you trying to achieve with your targeting campaign? Now, in the next couple of slides, what I'd like to do is talk about execution. And this execution is typically where modeling plays a heavy role. Now, in order to talk about modeling, we'd first need to at least come up with some kind of a mathematical formulation for the kind of problem we're dealing with. And I'm going to show you two examples of these kinds of mathematical formulation. And so what is the question here? The question here is, can we identify a set of customers from the entire population of customers who will maximize the expected profit of a targeting campaign? So this is one way of mathematically modeling a targeting campaign. You have a certain objective. In this case, let's say it's maximizing something. And what you'd like to do is, with respect to that objective, you'd like to identify the set of customers who will maximize that objective. In this case, it happens to be expected profit. Now, this framework isn't, or this optimization problem isn't really the best way to approach this. What is more frequently used is the following modeling framework, which is called the uplift modeling framework. And here, what is happening is that the customer is, instead of modeling the expected profit of a customer, what you're doing is you are looking at the difference. You're trying to maximize, that is, you're still trying to find a set of customers who will end up maximizing a certain mathematical quantity. And the mathematical quantity in question is this expression within the sum. Now, what is this exactly? This is basically the first term here, as you can see from the definition, the first term refers to the expected net value provided by these customers when targeted with a promotion or advertisement. The second term refers to the expected value of the customer when they are not targeted with a promotion or a advertising campaign. So what this quantity within the sum is capturing is that this quantity is capturing the expected net value when compared with the baseline. So this is something that wasn't present in the previous mathematical formulation. This is a formulation that, in this formulation, what you're doing is you're looking at the difference in the net value between someone who was targeted with a campaign versus someone who was not targeted with a campaign, with that same someone who wasn't targeted with a campaign. So what is going on here? Well, what's going on here is that basically you are trying to identify customers who will respond to your marketing action. So that's what's captured in the first term of the sum. You are trying to find out you're trying to identify customers who are susceptible to the promotion that you are going to expose them to. And hopefully that that marketing action will enable them to take a certain marketing action. And then what you're trying to do is you are looking at the behavior also of those people when they were not targeted with a campaign. So what the idea here is you are trying to compare the behavior of a customer when exposed to a campaign versus their behavior when they were not exposed to a campaign. And what you would like to do is you'd like to maximize the difference in the value in the difference of these values. Now, whenever we talk about expected values, really what we're talking about is we're talking about some kind of probabilistic modeling going on behind the scenes. And what are we really talking about here? Well, we're really talking about the probability that someone will respond to a campaign versus the probability that someone will not respond to a campaign. And when you have stuff like this, when you're trying to find out whether someone will respond to a certain action versus not responding to a certain action, this very easily leads to these kinds of soft classification models. So let me hopefully, if the previous slide was not very clear, let's just take a look at this in a more diagrammatic manner. And what we're doing here is essentially the quantity on the x-axis refers to the first term. So you're looking at the probability of a customer when they are treated with a certain campaign. The second quantity refers to the probability in the y-axis. So basically, you're looking at the response probability if they are not treated with a campaign. So the idea here is what you're looking at is you're looking at the probability with respect to a certain action taken by the customer. And what you'd like to find out is whether this customer will take the action when exposed to a campaign. And what is the probability that this customer will take the action when they are not treated with the campaign? And in the bottom right-hand corner of this picture, you have examples of people or customers whom you want to target. These are customers who have a high response probability of taking an action when treated with a campaign, and they don't have a high probability of taking that action when they are not treated. Similarly, here you have people who are who work in the opposite way. Here you have people who are likely to act when they are not treated with a campaign, when they're not exposed to a campaign. And here you have people who are going to be treated, who are going to take the action when they are treated. So what you can do then is for each customer, you can classify them into certain categories. You can look at whether they are persuadable, whether they shouldn't be disturbed, because really they are not responding positively to the campaign, and also whether they are sure things. So who are these customers? Well, these customers are people who would have ended up going to the store irrespective of whether they were faced with a campaign or not. So these are people who don't really need to be exposed to the targeting campaign, because they would have gone, they have a high probability of taking the action, whether they were treated or whether they were not treated. So when you have a targeting campaign and when you are trying to maximize quantities like ROI, you're trying to be as efficient as possible. You're trying to capture people who wouldn't have gone if you hadn't exposed them to the targeted campaign. And you really capturing people who would have gone irrespective of whether you exposed to the campaign is probably a drain on dollars. So the idea here is you can expect, so the main thing I want to convey with these couple of slides and this picture really is that there is a way of framing a targeting campaign in a mathematical framework or an optimization framework. And once you have that framework, very naturally, you can start talking about classification type models where, given a customer, you can ask yourself whether that customer is likely to respond to a campaign or whether that customer's behavior is going to be unchanged because of that campaign. And so once you have these kinds of, once you have this framework in place, the next step is basically deciding how you want to execute the framework. How are you going to execute this kind of how are you going to tackle this optimization problem, whether it's a lift problem or whether it's the conventional profit maximization problem? What kind of tools are you going to deploy or employ in order to tackle these issues? And this is where you have basically models such as propensity models. That is, you'd like to ask yourself, well, what is the propensity for someone to take a certain action? We'll go into this in more detail in just a moment. You also have time to event models. You also have stuff like lifetime value models. So together, by no means is this delineation of models complete. But what this does is it shows you that, I hope to show you that within this framework of answering an optimization kind of problem, within this framework, you can basically translate the problem into a modeling problem. And once you translate that into a modeling problem, then you're essentially dealing with either a propensity model, maybe you're dealing with a time to event model, or whether you're dealing with a lifetime value model. So let's take a look at propensity models in more detail.
Hari, before we go into the details, there are some questions from the previous slides.
Okay.
So the first one, I think, was regarding the, so it's, if we're maximizing the difference between the two distributions, is that the same as saying maximize the amount of white area in the diagram? So
no. So yeah. So that's a good question. So really, and you're not really maximizing. So this white area is with respect to a certain customer. What you're really trying to do is you're in the previous question, in this formulation right here, you're trying to identify those customers for whom the green area is as large as possible. So you're trying to identify the customers who are persuadable. So this kind of a picture, so maybe I should have been a little bit more explicit here, but this picture really refers to the viewpoint of a single customer. Whereas in the previous formulation, you're looking at a subset of customers. So you can use the diagram to identify those customers who will maximize this difference. And those customers are precisely the customers who will fall into the green area of that diagram.
I see. So it's like a classification or categorization problem in this diagram.
Exactly. So you are converting an optimization problem into a soft classification problem. You could make this a hard classification problem by doing a yes, no, or into a 2x2 grid of yes or no's. But you are converting this into a soft classification by looking at the probability of them taking a certain action when exposed to a targeting campaign, and also when they are not exposed to a targeting campaign.
I see. So there's a second question. What methods do we use first to see these differences, KI divergence or something else? I think might be regarding the first, the previous
yes.
one.
So yeah, you can use a more more probabilistic frameworks, like exactly like using KL divergence or stuff like that. But I will go into that in detail when I talk about measurement. But just to set that up, the main tool that we use when we do this is very quickly speaking, we basically use randomized control trials. So in other words, A/B testing. You run a campaign, and then you look at the. So in other words, you run a campaign. You look at the difference. This takes place after the modeling is taking place. But here, the maximization. You don't really address this problem directly. You address this problem via the use of a kind of marketing measurement kind of marketing. You address this problem in the measurement aspect, or what you do is you address this problem by going to a classification type problem. So you don't, most of the time, if you try to address that problem directly, especially when you're dealing with a large store or when you're dealing with a huge customer base, this problem becomes very quickly very intractable, especially because you'll be dealing with millions of probability distributions. So really what you do is, in order to make this problem tractable, or in order to make it solvable, you, for each customer or for a group of customers, what you do is you turn it into some kind of a classification problem, and then you address the classification problem you address the classification problem to deal with this optimization aspect.
Gotcha. Thanks.
So just again, so since we're talking about this modeling aspect of things, I just wanted to quickly go over, because, and again, it relates to the last question that I just had, wherein propensity modeling is really it's one of the foundational techniques used very heavily in trying to figure out how to pick your customer base. How do you pick a customer base that is very responsive to a campaign, and not responsive when they don't get the campaign? So just to quickly go over propensity modeling, the idea here is, what you'd like to do is you'd like to identify groups or sets of customers who have a certain propensity to take a certain action. So that action could be something like buying more in a given week, or maybe these might be customers who have a propensity to churn. It really depends upon the objective that you have in mind. The objective you have in mind will decide the action, and that action will in turn decide the kind of propensity modeling that you want to take in, that you want to use. So you have a kind of propensity modeling to figure out what kinds of customers are going to take that action. Then under the umbrella of propensity modeling, really, you also have lookalike modeling. And lookalike modeling also goes back to what I just mentioned earlier. Maybe I wasn't really clear about that. But the idea is, in order to maximize this difference right here, just to go back here, in order to maximize this difference, sometimes, and in fact, maybe I should say frequently, what retail firms or what even brands do is they run a pilot campaign. So they run a pilot campaign, and they on a certain subset of their population, and on the subset of their population, they try to identify people, or they identify people who were exposed, who took the marketing action corresponding to that campaign. So in other words, they identify customers who had a positive response to the first term in this sum. Now what you do then is, in order to maximize the difference, what the lookalike modeling does is, the lookalike modeling then identifies customers who responded positively in the pilot campaign. What is then done is, features are then built on those customers who responded positively in the pilot campaign. And once those features are identified, a lookalike model is built over the entire customer base. So you run a pilot campaign on a small subset of the population, and then you expand whatever it is that you've learned from that pilot campaign, you extrapolate it to the entire customer population. And that's where lookalike modeling comes into play. So it's also another way of trying to maximize that uplift response modeling framework. And again, you don't tackle the optimization problem directly, you kind of bypass it by using, in this case, pilot campaigns. So lookalike models, very popular, very convenient, and also allows, and again, the success or failure of the lookalike model really depends upon the kind of features you have at your disposal. But if your feature base is rich enough, then it should be conceivable. In practice, it should be conceivable for you to expand and identify those customers who are susceptible to this kind of campaign targeting. The other kind of modeling that's done, and this is almost ubiquitous. It's done everywhere. It is an old technique. It's also a new technique, depending on how you want to look at it. It's a segmentation. Segmentation can be done using a single attribute. You could do something like segmentation based on the average spend. Now, that by itself is not very useful, but it has been done previously. You could also do something called recency frequency monitoring modeling. That's the RFM modeling. And here, this is basically a kind of this is a kind of segmentation where you segment customers based on the recency of their purchase history, on the frequency of their purchase history, and how much they're spending. And it is very successful. It's always very useful as a first line of attack, primarily because it's so simple. It doesn't require the use of any sophisticated ML techniques. But the problem with RFM modeling and all the traditional segmentation modeling techniques is that they aren't very behavioral. You are segmenting customers based on the actions that they have taken. And that in and of itself isn't very useful. What you'd really like to do is you'd like to segment customers based on their behaviors, on their personas. And again, this requires probably some kind of clustering. And also, it is very heavily reliant on the kind of features you have at your disposal. What kind of customers are? What do they interact with? What is their pattern of purchasing? So, in some sense, RFM modeling is you could think of it as a weaker version of this kind of behavioral segmentation. And nowadays, a lot of retail chains or brands very heavily use this kind of behavioral segmentation, because especially when online comes into play. In the online world, capturing signals is very easy because everything is captured. Every mouse click, everywhere where your mouse has traveled to, what pages you visited. It's very easy to capture that sort of information. So behavioral segmentation is a very it's a field it's a field in and of itself. And it's very heavily used and by a lot of marketers to understand the people they're dealing with. And these segmentation models they could be they typically run batch-wise, so they may be refreshed once every quarter or maybe once a year even, depending on how stable or how active the customer channel is for a particular brand. And finally, we have lifetime value modeling. So lifetime value modeling goes back to that customer life cycle journey that we talked about earlier. And here, basically, the idea is what you want to do is, especially with those long-term goals in mind, you want to get an estimate of how valuable a customer is for a brand. So you want to estimate the total amount of money that can be made over the lifetime of a customer. Now, this can again be done. It can be done very simply. You don't really need a lot of sophisticated tools to do this. But recently, I maybe probably starting with the 1990s onwards, a lot of effort has been put into looking at stuff like Markov chain modeling for this. So people try to use Markov chain models to kind of guess the state at which a customer is at a given moment in time, and then to estimate where the customer might end up at in the next iteration. And based on where they end up at, what you can then do is you can adopt some kind of, you can create like a Markov decision process wherein you can channel them into the right state by treating them with the right marketing actions. So again, this is there's a lot of potential here, a lot of scope here, depending on how you want to adopt or what kind of techniques you want to use in modeling the customer base that you have at your disposal. Finally, I just want to touch a little about time to event models. So we talked a little bit about propensity models. Propensity models are answer the question of how likely is it that someone is going to take a certain action, or what kind of a customer are you dealing with? But it really doesn't tell you when a customer will take a certain action. That's where time to event models come into play. Let's say you're giving someone a certain promotion. You wouldn't want to give them a promotion when you know that they are definitely going to go shopping. You'd like to probably give them a promotion when they are not likely to visit the store, because in that case, what happens is when they do visit the store as a result of your targeting or marketing campaign, that will directly result in an increase in the lift, either by sales or either by customer conversion. So knowing when a customer is going to take an action is a very important aspect of modeling. And it's usually done by, you could use time series analysis here. So forecasting models come heavily into play here. Survival analysis models also come into play very heavily. So these are, these are just, this is just, what I want to emphasize here is these are just, this is just one way of looking at how to model customer behavior. Sometimes the question of how a customer is going to respond to a campaign is very closely intertwined with when a customer is going to do that. So there, in that case, maybe splitting the propensity and the time to event models isn't really ideal. Maybe you'd want to combine them into a single model. You'd want to use some more sophisticated forecasting model to get that into play. But what I've shown you just here is just an example of just a small sample of models that are used in the promotion and targeting campaign aspect of marketing. Now, I really wanted to go over and talk about online advertising, but in the interest of time, I just want to mention that everything that we've talked about earlier, insofar as the modeling is concerned, applies to online advertising. Online advertising is, in fact, probably the first success story of this kind of programmatic marketing practice, because again, it's the nature of online it's the nature of the World Wide Web itself. Every mouse click, every ad visited, every web page visited, this information is readily available. And the nature of online advertising is also very different from offline advertising. In offline advertising, what happens is that the retailers or the brands themselves engage with their marketing campaigns. Whereas in online advertising, usually you have these kinds of brokers, you have these kinds of advertising agencies that act as a sort of middleman. So that's the advertiser right here. So typically a brand will engage the purposes of, or the services of an advertiser, and maybe multiple advertising agencies. These advertising agencies then also have a sophisticated system of finding out the inventory of ad space. Now, usually this inventory of ad space goes through what is called an ad exchange. So an ad exchange is where a bunch of advertising agencies just sign in or log in, and they keep track of what kind of advertising space is available. And Google has an ad exchange, for example, Facebook. So the idea here is advertisers constantly monitor what ad space is available, what ad space isn't available. An auction process is also run, what's it called, a real-time bidding process is also run at the same time to basically sell these advertising spaces to the advertising agencies. And once these advertisers or advertising agencies get a hold of the inventory or get a hold of the advertising space on a web page, for example, then it becomes a matter of attribution. So then basically what these advertising agencies do is they have what you call beacons. So they track the activities of someone who happens to click on that ad, and they try to find out how effective that ad was, whether that ad actually led to a product sale or not. So then it becomes a question of attribution modeling. This online advertising ecosystem is, again, It's a completely separate. It's almost an entirely different world when you compare it with offline advertising, and that's because online advertising is the nature. It's a much easier way to capture signals or capture features and then float those features back to the respected parties, so that you can then target them in as granular a manner as possible. So online advertising is again probably as I mentioned earlier, probably the field where this kind of programmatic marketing practices initially first came into the forefront. The other thing I want to emphasize here is that there is a lot of tumult going on here. It's recently, for example, at the 2020 WDC conference, Apple announced that they were no longer going to give identity. Every device has what is called an IDFA number. So now Apple recently announced that IDFAs are no longer going to be no longer going to be given to advertisers. So it's purely going to be by opt-in, because consumers or customers have to opt in to surface or give the advertisers their IDFAs. And these IDFAs are very important because advertisers typically like to take a look at what a customer is doing on a device. They're not interested in what goes on in a specific app per se, but they're interested in how the customer interacts across all the apps. Now, with the loss of the IDFA, this kind of information suddenly is no longer available to the advertisers. This is a very recent change. It's also sent a lot of, it's almost like an earthquake in the online advertising industry, because now advertisers have to find a way to get around this, because it's going to be very likely that not many customers are going to agree to give their IDFAs to advertising agencies. Privacy is a big issue these days. So now this field is on the verge of a major change, a major overhaul. How do you track attribution? How do you track device activity when you don't have access to the devices themselves? So, this is probably the subject of a talk that we can do later on, but online advertising is worthy of a mention in and of itself. And finally, the last thing I want to talk about, and probably this is in fact one of my topics of interest, and is something that I would like to spend time going over in more detail, probably by getting people who have written papers, who have invested heavily in this topic, is response measurement. So the idea here is you've run your campaign, you've found what you think are the right set of customers, and now you're going to see how effective your campaign was. Because how effective your campaign was will in turn let you know what you need to tweak insofar as your campaign is concerned. And this is where measurement comes into play. And this is, again, a field. It's usually when people talk about machine learning, they focus on the techniques, they focus on deep learning or other kinds of techniques. But I feel that measurement is probably the most important aspect of any kind of marketing campaign, because if your measurement is flawed, then you lose any kind of visibility into what you're actually doing with your marketing campaign. And in this field, or in this subfield, there are essentially two main ways of doing this, and that's by the use of randomized controlled trials or randomized experiments. These are what you would call them A/B tests, or you could use observational studies. And remember, the main goal here of any kind of measurement process is to attribute a causal relationship between your marketing action and the outcome of the marketing action. You want to be sure that or as sure as possible that the customer took that action because of your marketing campaign. And that kind of causal relationship or causal study is not very easy to do. In fact, causal machine learning is a field that could probably also help here as well. In future Spotlight talks, I hope to get speakers who have written papers in this field and who also have some experience with this, because I do feel like not enough attention is being given to this aspect of measurement. And just to emphasize the importance of, let's say, randomized control trials, randomized control trials are probably the gold standard. You divide your population into two groups, a test and a control, and that very quickly tells that very quickly tells you how effective your campaign was. Now, again, even within the world of randomized control trials, there are things that you need to watch out for. You can't just split them or sample them, willy-nilly in a 50-50 kind of way. You probably need to do some kind of statistical matching to make sure that what you have at the end of the day is statistically valid. So this is probably a field where statistics or the statistical validity plays a very important role. Another point to emphasize this is that in 2019, for example, the Nobel Prize in Economics was given to Esther Duflo and others, and these economists were given the Nobel Prize because they pioneered the study of randomized controlled trials in economic interventions. So basically, they basically pioneered this field of looking at how economic or developmental interventions affected entire populations. So this is very important. It's probably the thing that you want. Ideally, in an ideal world, this is probably what you want. You want a randomized control trial, and if it's done effectively and if it's done in a statistically valid manner, you can tell yourself that what you see or the effect that you see is as close to ground reality as possible. Now, unfortunately, this is not always going to be the case. When you're working in the online advertising world, for example, your ads or whatever targeting campaign that you do goes through what is called a real-time bidding system. Because the inventory is not readily available, so there's a process that kind of filters out the campaign. That if you don't have the control over the campaign and the people to whom you're exposing the campaign to. That occurs at the hands of the advertising agencies. So then any notion of a randomized control trial falls out of the window, because no longer can you control your populations into a test or can you strictly delineate your populations into a test population or a control population. So in that case, you have to resort to what are called observational studies. And in observational studies, you typically, there are many statistical tools available at your disposal. Some of them are better than the others. So for example, Julia Pearl, a professor at Berkeley, has pioneered the use of these kinds of Bayesian networks. So Bayesian networks is one way of trying to get that kind of causal attribution. And this is also where causal machine learning techniques can come heavily into play as well. It's in the observational studies where you don't have a specifically defined test or control group. So you have to do some kind of analysis on top of the results that you see to extract the meaningful signal or the causal signal of your marketing action. So this is, again, worthy of a talk in and of itself, primarily because these techniques can get quite sophisticated, statistically speaking, or they can be very simple, especially when you have access to an A/B test. But then you also have to ask yourself, well, if you're running an A/B test, how long do you want to run the A/B test for? When do you stop running your A/B test? So on and so forth. So questions like this will play a very important role in determining the kind of signal you get from your marketing campaign. And these signals will in turn let you know what kind of levers you need to change in order to affect a new marketing campaign. So if you want to use a new marketing campaign, well, maybe the subset of customers I chose originally wasn't that great. Or maybe I need to use a slightly different objective. Or maybe I need to slightly change the kind of attribute that I'm going after, the kind of feature that I'm training my model on. So the measurement, while it does appear at the end of this talk, is probably the most important aspect of a marketing campaign, because it lets you know what works and what doesn't work. And with that, I think I hope I've given you an idea of the kind of programmatic marketing pipeline that you might see in different brands or retailers. These pipelines, the way I've presented them is probably a very simplified perspective. It's not usually in a company you would have multiple teams all probably having their finger in these kinds of campaigns. So it's not going to be that clearly or strictly speaking clean. But at the end of the day, when you use this kind of a programmatic marketing abstraction, it lets you know what it is that you are trying to achieve, how you're going to achieve it, and finally, whether what you achieved really ended up working in your favor or not. So that is the content of this talk, and that's what I wanted to go over in this session right here.
All right. Yeah, thank you so much. I definitely agree. Having worked in, I've worked on some models like churn models that deal with, basically the use case that you've outlined. And there's a lot of exciting stuff that touches on other fields. Like I've worked on recommender systems as well. And you're totally right that they interplay or interconnect into marketing as well. So just in the interest of time, we can only have one last question. If you could give like a 20-second answer.
Okay.
So what are common methods used to measure impact of a campaign in the absence of A/B testing?
So in the absence of A/B testing, so if you don't have a strict test and control, the idea then is what you can do is, let's say you have you have to then basically divide your customer group into people who, let's say, were exposed to the campaign, people who weren't exposed to the campaign. So in some sense, you can still create test and control groups, but not in the sense of an A/B test. Once you do that, there are methods, there are statistical methods. Again, I'm probably going to run out of time, and hopefully we'll get to this in a later talk, but there are these intent to treat talks, so intent to treat methods, and they're called, I don't remember the exact acronym at the time, but you can look up at intention to treat models. So these intention to treat models, what they do is they try to filter out these additional noise that might be gained by losing control over strict test and control groups. And once you overlay that model on top of on your top of the customer base, then you can get an idea of how effective your campaign was. Again, I can probably bring that up at a later talk, but you might want to look at something called intention to treat based models. That should give you some idea of how you might be able to still get a valid test and control measurement out of something that's not a randomized control trial.
All right, sounds good. Yeah, thanks so much for the answer, and thanks everyone for joining. We have many more sessions like this on a regular basis, so feel free to subscribe or just check our channel for any updates. So thank you very much and have a great day.
Thank you.